A journey through the cosmic scale. From moons to the edge of the universe not long ago, I came across an experiment inspired by a Veritasium video. The question posed sounded straightforward. Arrange these from largest to smallest: moons, planets, galaxies, stars, and the universe. You might think the order is obvious, but many people guessed wrong. Some even believed stars were the smallest objects listed, forgetting that our sun is itself a star, and vastly larger than any planet. It's clear we sometimes need a reality check to grasp how huge the cosmos truly is. So, let us set off on a journey, from the humble size of planets to the mind-bending scale of galaxies, black holes, and the universe itself. We all know the sun dwarfs Earth, but knowing a fact and feeling its magnitude are two very different things. The sun is about 110 Earths wide, but that number barely registers until you see it visualized. Imagine one grain of rice representing Earth, everything. Every human who has ever lived or ever will live exists on that tiny grain. It would take about 1,300 Earth grains to equal the volume of Jupiter and the Sun. You'd need 1.3 million Earth grains to fill it. In fact, if you took the total mass of every planet, moon, asteroid, and comet in our solar system, the Sun alone would account for 99.86% of it. Jupiter and Saturn hold most of what's left, leaving Earth's mass almost negligible in comparison. And Mercury, at just 40% the size of Earth. It's barely larger than our moon. You could fit the entire continent of Asia on its surface. Speaking of the moon, here's something that surprises people. If Earth were the size of a regular globe, the moon would be a ball about a quarter of that size. Most imagine the moon orbiting nearby, but at that scale, it would actually be 4.6 meters away, equivalent to 300,000 real miles. That gap is so large you could fit every planet in the solar system between the Earth and Moon. Suddenly, the Apollo missions seem even more incredible. Now, let's look beyond planets and into the realm of stars. Our Sun is a main sequence star, a stable, middle-aged hydrogen fusor. 90% of all stars fall into this category, ranging from cool red dwarfs to blazing blue giants. But stars come in a staggering range of sizes. White dwarfs, for example, are the remnants of small stars, Earth-sized, yet far denser than our Sun. Smaller still are neutron stars, city-sized spheres so dense that a teaspoon of their matter would weigh billions of tons. Then there are supergiants like Betelgeuse, hundreds of times the Sun's size, and the even larger Hypergiants. One monster, Woe G64, is about 1,540 times wider than the Sun. If it replaced the Sun, its surface would stretch nearly to Saturn's orbit. Yet even the biggest stars are no match for black holes. These cosmic traps come in different scales, but the most astonishing are supermassive black holes, found at the hearts of most galaxies. Our own Milky Way hosts Sagittarius A*, a 4 million solar mass giant, located 26,000 light-years away. We've even photographed it thanks to the Event Horizon Telescope's Earth-sized network of radio dishes. And then there's TON 618, the largest known black hole. It's so vast, you could place 11 solar systems inside its event horizon, containing the mass of about 70 billion suns. It lies 18 billion light-years from us, and we see it as it was 10 billion years ago, meaning it's likely even bigger now. Beyond black holes, we encounter galaxies, vast collections of stars, planets, and gas. Our Milky Way spans 100,000 light-years and holds roughly 100 billion stars. But the giant IC 1101 blows it away, with 100 trillion stars across 5.5 million light-years. And finally, we arrive at the largest thing of all, the universe itself. Even traveling at light speed to 300 million meters per second, it would take 8 minutes to reach the sun, for years to reach the nearest star, 2.5 million years to reach Andromeda, 45 billion years to reach the edge of the observable universe. And that's just the observable part. Inside it are an estimated 2 trillion galaxies, each with hundreds of billions of stars. There are more planets in the universe than grains of sand on every beach and desert on Earth. And not just a few more, but orders of magnitude more. With numbers like that, the idea that Earth is the only planet with life seems not only unlikely, but almost absurd.